So this one is an assignment related to topic polarization. The first four questions already I have discussed. So we'll start with question 5 onward. So in question number 5, the refractometer are used in food manufacturing industry to measure the concentration of a sugar in different drinks. Like what is the concentration of a sugar in different drinks? We can use this refractometer. The idea is that like the higher concentration of the sugar means it will rotate the polarized light. If you are passing a polarized light, greater the amount of concentration of a sugar, greater the refraction, or it will rotate the plane polarized light. So as the concentration of the sugar increases, the refractive index of a liquid also increases. A simple refractometer uses a hollow prism, like this prism is hollow, and then it can be filled with different liquids. So how we can identify what is the amount of sugar? If the high concentration of the sugar, light will refract or bend away from bend towards the normal mode when it travels from air to glass. If it is having a low concentration of sugar, then the refraction will be smaller. The simplified diagram below shows a ray of a light passing through a prism filled with a liquid. The liquid is replaced with one with a higher concentration. Like right now, there is one liquid present, but now we are using a liquid with a high concentration. Use the same incident ray, draw the path of a new, draw the new path through the liquid and out of the prism. So if the high concentration is there, greater the concentration, higher refractive index, so more bending. So when we draw the normal is always perpendicular to the surface. So which one is the right path? If I draw more towards or like less refraction, more refraction, which one is the correct path? A or B? This one is A.
B.
B is the correct path. And then same thing, bending away from the normal when it travels, so it will further bend away from normal. This is, we have to complete as a to show how a refraction, so it should be a greater refraction. Then in practice, a laser beam is shown through the empty prism. The position of the emergent ray is marked on the screen. Like when there is an empty prism, this is how the ray emerged out. The prism is now filled with a liquid with a known concentration, and displacement on the screen is recorded. So how much it displaces? Because when there is no liquid, like the light is not changing the medium, that's why it does not change the path. It continues to move in a straight line. But when there is a liquid inside, it is having a higher refractive index, so it will bend towards the normal and then bend away from normal. So with sugar solution or a liquid and without liquid, their light is taking different path. And we measure the distance, how much displacement it have occurred from the mean position, from the original position, for different concentrations of sugar solution. So there's a graph. This is repeated for a number of different known concentration. As you can see, the graph shows how the displacement vary with the sugar concentration. Like if you have a sugar concentration, 20% displacement is about like 55, 40% displacement is about 62, 60% displacement about 76, and so on. Describe how the displacement vary with the sugar concentration. So how the displacement is related with the sugar concentration. So displacement is increasing as the concentration increase, but we cannot say they are directly proportional. Why we cannot say they are directly proportional? Because if it was a directly proportional relation, it should be a straight line which is starting from origin, like 0, 0. We can say increase in displacement, increase in concentration of a sugar increases the displacement of a light, but it is not directly proportional, or it is not a linear relation. Why? Because it's making a curve. It's not making a straight line. So when it's not making a straight line, it means that it is a non-linear relation. and the displacement increase with the concentration of sugar. So if we use high concentration of a sugar, displacement will be more.
Okay.
Then a sample of unknown concentration produce a displacement of 88. Draw a line of best fit to find the fit on the graph and use it to find the sugar concentration. So what we will do, we'll complete this. Like here, line of best fit can be a curve. It's not like necessary that it should be a straight line. Line of best fit can be a curve. So we join this point, a freehand drawing will be there. And when it is 88, what is the concentration of a sugar? So 82, 84, 80, 82, 84, 86, 88. This one is 88. So from 88, we'll draw a line and then we'll find the concentration. On each box is representing 2 on x-axis. So this is 70, 72, 74. So this one is 74. So the concentration of the sugar solution is about 74%. Is it clear? This one?
Yes, sir, it's clear.
Okay. Then give a reason why the distance between the screen and the prism must be kept constant. Like why this distance, the position or the distance between the screen and the prism, that must be kept constant. Because what might happen if we change the distance between the screen and the prism, then it will affect the displacement. Because, for example, if the prism is placed nearby if the prism was placed nearby, then the displacement of for the same concentration will be like this is if the light passes straight, but this one is. So for the same concentration, the displacement will be different. Same thing, if the prism is placed away from the screen, and more towards the source of a light or a laser. This is if there was no liquid present, and if there's a liquid present, then in that case, light has to cover a greater distance. As a result, the displacement will increase. So why this distance between the prism and the screen must be kept constant? Because it can affect the displacement. So one mark is there, we'll just mention that it can affect the displacement. Then another method of measuring a sugar concentration uses polarized light. What is meant by the polarized light? What is the definition of the polarized light? So the polarized light means light which is having
With single component.
yeah. So that, but you have to learn a standard definition. So light which is having only one component, and two things are different. Like there are two definitions, two ways we can define a polarized light. One is a polarized light is the one in which the oscillation or vibration are in one plane only, and plane include the direction of travel. If I use the term plane, so light with single or one oscillation so light with a one component of oscillation, or light with oscillation in one plane which include the direction of the travel. So if you use the term plane like the axis, then you have to mention that it is in the same plane as the direction of travel. But you can also use the term the light in which the oscillation in one direction, and that direction is perpendicular to direction of the wave. So if you use the term direction, so light with oscillation or vibration in one direction which is perpendicular to direction of travel or direction in which the wave travel. So these are important points. Either you can define it both ways. If you use the term plane, then you should mention that the plane include the direction of travel. But if you use the term oscillation in one direction, that oscillation is perpendicular to direction of the wave. So any one of them you can write, but remember that when you're writing, you should be sure like whether you use the term plane or you use the term direction.
Okay, sir.
Okay. The next one, when polarized light passes through a sugar solution, the plane polarized rotate through an angle. How to measure this angle of rotation? Like what they mean here, example, we have a container which is filled with say a liquid and we are passing a polarized light. So when it passes through, it rotates the polarized light because polarized light can be rotated as well. So as a result, so it rotates the polarized light either clockwise or anti-clockwise. So the higher concentration means greater rotation is there. So how we can use it to work out the concentration of a sugar solution? So what we do, first we have a polarizer. Then in a container, we have a sugar solution. And first it is not filled. Like example, there is no liquid inside. And then we have an analyzer. Because normally the source of the light which we have, these all are unpolarized light. Light will have multiple component of vibration. So example, it is a vertical polarizing filter. So it will allow only vertical component of a light to pass. Then there is nothing in the beginning, there is nothing present. So the light will pass in the same way. And we place the polarizing filter. Same as like analyzer, same as the polarizer, the first one. And we'll see the light or observe the light. Other end. Now what we will do, we will fill it with a known concentration of a sugar solution. As a result, because sugar solution, what is the tendency of this sugar solution? It has a tendency to rotate the polarized light, either clockwise or anti-clockwise. So as a result, because it will rotate the light, in that case, there is no vertical component here. As there is no vertical component, so we will not observe any light. There will be no light present. Now we will gradually rotate this polarizing filter to like we can measure the angle. So we rotate this polarizing filter. As a result, when we rotate this polarizing filter, now what will happen? Again, because right now we are not able to see any light, but once we rotate the polarizing filter and it's plane parallel to the component of the light, now again we are able to see the light. So if we are able to see the light, we'll record that angle, how much we rotated this polarizing filter. with this concentration of a sugar solution. And then we'll plot a graph between concentration of a sugar solution and the angle. We can take angle on or percentage of the concentration of sugar solution and the angle at which we are able to see the light again. And using this graph, we can determine if a higher concentration is there, it will rotate the polarized light to a greater angle. So again, it will start to increase, like this type of graph will be there. So using the angle, we can determine the concentration of unknown solution. Is it clear how we work out the concentration of a sugar solution with unknown concentration?
Yes, sir. The angle is on y-axis, right?
Angle is on y-axis. It can be other way around, but angle is on y-axis and the sugar concentration is on x-axis. So same thing we will repeat with unknown solution x, and we'll determine at what angle the light again appear to us. And the angle at which the light appear to us, from that angle we will find what is the concentration of that specific sugar solution.
Okay, sir.
In question 6, it is often difficult to see below surface of a pond because of a glare. This is when the intensity of a light from the sky reflected from the surface is much greater than the light below the surface. Sunglasses with polarizing lenses can reduce the effect of a glare, allowing the observer to see clearly what is below the surface of the water. This is because light from the sun becomes plane polarized when it is reflected, and explain the difference between the plane polarized and unpolarized light. So the difference between a plane polarized and unpolarized light means light which is having oscillation or vibration in many planes, or polarized is light which is having oscillation or vibration in a single plane. And if I use the term direction, then I will mention it is perpendicular to direction of propagation. And if I use the term plane, then I will say that the direction of a propagation include the plane as well. So unpolarized.
What is the definition of unpolarized light?
Unpolarized means light or which is having many oscillation in many directions. Unpolarized means which is having many oscillations or vibration. And polarized means single oscillation in one direction, which is perpendicular to direction of propagation. The direction in which it propagate or move, that direction is perpendicular to direction of the vibration. Explain how the polarizing lens may be used to remove the glare, but still allow the light from below the surface of a pond to reach the observer. So this we already discussed yesterday. By example, if this is a water level, the light which is coming from the sun is an unpolarized light initially, because it is having many components of vibration. So this light is unpolarized. But when this light is reflected from the surface, when this light is reflected, due to reflection also, the light can be polarized. This is partially polarized. Partially polarized means most of the components are reduced. There is only one component which left. Other are there, but this is called partially polarized. So this is according to the surface, it is polarized. And objects which are underwater and the light is reflected from those objects which are under the water, because refraction does not polarize the light, reflection can polarize the light. So this is the unpolarized light again. And when it is coming to eye, we are receiving both of them. So that's why we observe the reflection and the refraction object, but that's not clear because both are we are receiving. But if we use sunglasses, and these sunglasses, the goggles are vertical polarized. So as a result, what will happen? It blocks the horizontal component. So it only allows the vertical component to pass through. But this is having horizontal, so it is completely blocked. Only vertical components are able to pass through. So the vertical components are due to the object which are under, like coming from the object which are underwater. So we are able to see the object clearly which are underwater. So how you will write the answer for this? So the idea is that the plane of the polarized light, like this plane of the polarized light which is reflected from the sun, should be perpendicular to the polarizer, or 90 degrees. The angle between them should be 90 degrees, so it will block all the light. So glare or the reflection is blocked or absorbed by the lens. But light which is from the light from a below surface is almost unpolarized, and this light is able to pass through, or one component of the light is passed through. Rest all are blocked. Only some of the light from the below surface is blocked or absorbed, and remaining, which is parallel to the plane, will pass through. So we are able to see the object which are under water. So this you have to write in your own words. Is it clear that how we are able to see the object which are underwater, but instead of the reflection?
Yes, sir, clear.
Okay. You should be able to write this in your own words. Then in question 7, light from the sun is unpolarized. So what is meant by unpolarized light, or definition of unpolarized light? So oscillation or vibration occur in many directions, which are all perpendicular to direction of the propagation. It's of 2 marks. So oscillation or vibrations occur in all directions, which is perpendicular to direction of propagation. The direction in which it propagates, that will be different. Then when a ray of a light from a sun is incident on a block of ice, the most of the light is refracted into the ice and some of the light is reflected. The light which is reflected is partially polarized. Describe a test to confirm that the reflected ray is partially plane polarized. Like a similar question, that example, we have an ice cube or a slab is there. So what they're saying, the light which is reflected from the surface. As a result of a reflection, the light can be polarized. So as a result, what will happen when the light strike and bounce back? This is partially plane polarized. Other components are reduced. And the light which enter and bounce back, it is still unpolarized light. So how we can confirm that the light is polarized? Like the light which is mainly, we don't have to bother about the refracted one. The reflected one, we have to tell that the reflected one is a polarized light. So how we can test this? It's a polarized. So we can use a polarizing filter, and we rotate this polarizing filter until we receive minimum and maximum. Like the intensity will change first when we place a polarizing filter parallel to the plane of the polarized light. We'll receive the maximum light, or most of the light will pass through. Then we start to rotate, and if we rotate it by 90 degree, because when we rotate by 90, the polarizing filter, so when we rotate by 90, there will be no light. Then again we rotate by 90, there will be again light again. So we'll use a polarizing filter, rotate the polarizing filter, and after every 90-degree rotation, the intensity of a light completely change. Like it will be minimum, maximum, minimum, maximum. That's how we can prove that the light which is reflected from the surface of the ice is a polarized light. Because if it was unpolarized light, even we are rotating, we will receive the light, we will receive a single component of a light every time. But if it is a polarized light, light which is having only one component of a vibration, so what will happen if the polarizing filter is parallel to the plane of the polarized light? Then we'll able to observe the light. But when the polarizing filter, the plane perpendicular, then there will be no light. Is it clear that how we can confirm that the light which is refracted from the surface of the ice is a polarized light, or partially plane polarized?
Yes, sir.
Some skiers wear sunglasses with polarizing lens. These sunglasses reduce the amount of reflection light entering to the eye. Suggest how these sunglasses work. So we have to explain the working of a sunglasses, how it works. So the same idea is there, that the reflected light or light from the ice is partially polarized, as we know in the beginning. So sunglasses, they have actually a polarizing filter, and that are their plane are right angle or perpendicular to the light. So they will block the light, or does not allow that light to enter the eye. So sunglasses, the reflected light from the eyes is polarized. Then what will happen? The sunglasses consist of polarizing filter, and as a result, when it consists of polarizing filter, the plane of the polarizing filter perpendicular to light, which block the component. or absorb the. You can use the term block or you can use the term absorb. That's how it reduces the reflection or the glare from the surface of ice. Then question 8, a student looks at the sunlight reflected off a puddle of water. You can see a similar questions are there. She puts a polarizing or polarized filter in front of her eye. As she rotates the polarizing filter, the puddle appears to be dark then lighter. Explain this observation. So, like student is observing the reflection from the puddle of water. So, light which is coming from the sun is an unpolarized light, which is having many components of vibration. By looking at the light, by looking at the difference is the intensities are different. By looking at the light, you cannot say it is polarized or unpolarized. As in, if you have a comparison, unpolarized light will have a low intensity as compared to polarized light. Unpolarized light will have a high intensity as compared to polarized light because it is having many components. But what happened due to reflection, as the light is reflected from the surface, it becomes horizontal polarized, or according to the plane of the reflecting surface, it is polarized partially. Now, student is using a polarizing filter. As she rotating a polarizing filter, she observed that it appeared dark and then light, dark and light. What is the reason for that? Because when the plane of the polarizing filter are perpendicular to the polarized light, then there will be no light and it will appear to be dark. But when the plane of the polarizing filter are parallel, as she rotate, and the plane of the polarizing filters are parallel, then the light is able to pass through. So she will observe right. So darker than lighter, or like light will appear or then it disappear. So what is the reason for that? So reflected light is the polarized light. That will give you 1 mark. Then polarized light is the one in which the propagation is perpendicular, or direction of polarized light is the one in which the vibration or oscillation are in one direction, which is perpendicular to direction of the wave. And when the polarizing filter, as we are rotating the polarizing filter, if the planes are parallel, it will appear light, but if the planes are perpendicular, it will appear dark. Is it clear?
Yes, sir.
So similar question. So this was about the assignment related to polarization.